Okay, so for number one, what is the answer in scientific notation? First thing you want to look at is the operation. Right now it's subtraction. Okay, so since what do you know about subtraction? You know you try to get the same exponent. You're going to either change this to a five, change this 5 to a 6, or this 6 to a 5, right? But you know, when after you subtract, once you get the same exponent, you don't subtract the exponents. You're looking for a like. You're keeping the exponent the same after you subtract. Okay, so you know it's not going to be b because look, it looks like the exponent's 1 there. 6 minus 5. You don't subtract 6 minus 5, and it looks like in C they're adding the exponents, and you don't want to do that. So you know right from the beginning it's not going to be B and C. Okay, so let's go ahead and so we're down to these two. Let's go ahead uh, and see what we get. So let's go ahead and change this 5 to a change it to a 6. So I made the exponent bigger, so I need to make the coefficient smaller. Okay, so I need to make it smaller by 1 decimal place. So I'm going to move it to the left 1. I didn't make it smaller. So this is 0.43 times 10 to the 6th. Okay, so this is 5.1 minus 0.43. So I can go ahead and subtract 5.1 minus 0.43. I can put a 0 in the by 1. Well, if I'm looking at this, 5.1 minus 0.43, it's not going to be 0.8. It's probably going to end up being this, but let's go ahead and subtract and make sure. Okay, so I'm going to go ahead and borrow this 0, 1, turn that into 0, and 10 minus 3 is 7. 0 minus 4 I can't do, so I'm going to borrow from the 5, make that a 4. I got 10 minus 4, which is 6, and I bring down the 4. 4.67 times 10 to the 6th. Okay, so that's why that one's D. Okay, all right, number 2, one type of ant is 0.0035 meters long. What is the length in scientific notation? Well, we know we're going to need a negative exponent. All these have negative exponents. Scientific notation, 35. That's not between 1 and 10. This is not scientific notation. 35, not between 1 and 10, not scientific notation. So if I have here 0.0035 and I move the decimal right there between the 3 and the 5, it looks like I've moved it past the 0, and the 3. So I need an exponent of 3. Okay, so this is the one that I want. Right, I have 1, 2, 3, 3 spaces there. Alright, let's take a look at number 3. A website gives the population of Europe as 16,700,000. What is the population to 3 significant figures? So you want the 1, 6, and 7, okay, which they have here in your answer. What is the population to 3 significant figures? Well, we want this in scientific notation, okay? So look at D. 167 is not between 1 and 10. We're going to cross that out. 16.7 is not between 1 and 10. We're going to cross it out. Okay, so I'm going to go ahead and write 167 and 1, 4, 6, 8, and 3. I'm going to replace with zeros because I only need 3 significant figures. Okay, so if I move the decimal between the 1 and the 6, and the decimal is here at the beginning, right? It looks like I move it past these 3 zeros, these 3 numbers, and then a 6. So 3 plus 3 plus 1, that's 7. Right? So let's count 1, 2, 3, 4, 5, 6, 7 places. Right? So this is option C. Okay. All right, number 4, what is the answer in scientific notation? It looks like we're multiplying. So remember, when we multiply, we add the exponents. Okay, so 9 plus 3 is 12. Well, it might be one of these. It's definitely not A. because 9 plus 3, 12 isn't anywhere close to 6, and it's also nowhere close to 27. Okay, so let's go ahead and multiply 6.4 times 3.2. 2 times 4 is 8. 2 times 6 is 12. Leave a space holder there. 3 times 4 is 12. Carry the 1. 3 times 6 is 18. Plus 1 is 19. So let's go ahead and bring down the 8. 2 plus 2 is 4. 1 plus 9 is 10. And it looks like I have 2 decimal places to move it. So it's 20.48. And then when I add the exponents, 9 plus 3 is 12. Right? The 9 plus 3 equals 12. So I have 20.48 times 10 to the 12. Well, I need to change it to a 2.048. Okay, so 2.048. I've made this number smaller. I need to make the exponent bigger, so that will be times 10 to the 13th. That's why this one ends up being B. Number 5, what is the correct power change? What is the correct power to change 76 million into scientific notation? Okay, so I need a number between 1 and 10. I would put the decimal between the 7 and the 6. It looks like I moved past the 6 zeros and the 6. That would make 7 spaces, right? So let's count 1, 2, 3, 4, 5, 6, 7, right? So the answer here would be C. Okay. So you put 7.6 times 10 to the 7. Alright, number 6. Alright, this one is an addition problem. So we know with addition, we try to get the same exponent. We don't add the exponents. We don't subtract the exponents. Okay. So I know I don't add the 9 and the 8. I shouldn't get anything close to 17. I don't subtract the 9 and the 8. I shouldn't get anything close to 1. Right. For addition, it looks like here, looks like I'm definitely going to end up with an exponent of 9. Okay. So let's go ahead and change this 8 to an exponent of 9, 10 to the 9th. I made the exponent bigger. I need to make this, the coefficient, smaller. So to make it smaller, I move it, the decimal to the left 1 space. So this is 0.76 times 10 to the 9th. Okay, so I'm going to add now. So this is the 1.2 plus 0.76. Let's add. I have the 6 here. 2 plus 7 is 9. Looks like it's 1.96, which is already between 1 and 10. I know the exponent is already 9 times 10 to the 9th. Okay, I don't need to change it. So there is the answer, B. Alright, the distance from Earth, the moon to Earth. And this one was one where you want to just choose the most appropriate units. Okay. So these are all the same number. It's 238,000, but different units. Okay, and the most appropriate one would be miles, right? From the Earth to the Moon, we would measure that in miles, and 238,000 miles would seem the most appropriate distance. Okay, number 8 through 10, we're using this chart that's given to us. So let's go ahead. All of these numbers here in the chart, okay, have exponents written. -6 is the exponent for red blood cells, -3 for a grain of sand, a +9 for the sun. Let's go ahead and change the moon to scientific notation so we have an exponent to read. So this would be 3.5 times 10 to the, if I put the decimal between the 3 and the 5, it starts at the end. It looks like I move it past these 6 numbers, right? 3 zeros, another 2 zeros, and the 5. That's 6 numbers. So this would be times 10 to the 6. So now we have all exponents to read, okay? Alright, which diameter is the greatest? So I want the biggest exponent. -6, -3, 6, and 9. Well, 9 is the biggest exponent, okay? So that would be the sun. What is the diameter of a grain of sand in standard notation? Well, let's look at a grain of sand right here. So I have 2.4 times 10 to the negative 3. So let's do the 2.4. It's negative. I move it to the left 3 spaces. Okay, 1, 2, 3. Right, and in here would go 0. So it's 0.0024. I need 2 zeros in front of the 2 after the decimal. Okay, so this would be option B. Number 10, compare a red blood cell to a grain of sand. Alright, so it looks like they both have negative exponents. Okay, negative 3 is the bigger number than negative 6. So we want to find one where it says the grain of sand is bigger than the red blood cell. Okay, so the grain of sand being bigger than the red blood cell is option B. Alright, number 11, what's the answer in scientific notation for 11? Well, it looks like I'm dividing. For division, you subtract exponents. Okay, you definitely don't add them. C is not even in scientific notation. We're going to cross out C. Okay, we don't add the exponents, so we shouldn't end up with anything close to 10 or 11. So I'm going to cross out D. Okay, so let's go ahead and divide 7.3 divided by 3.2. So let's set it up. 7.3 divided by 3.2. And let's go ahead and do some addition here, because we can see how many times 3.2 will fit into 7.3. So it might fit in twice, it might fit in 4 times. Let's go ahead and take a look. Okay, so I would do 3.2 plus 3.2. That gives me a 6.4. Okay, if I do another 3.2, that would give me 9.6. Look, that would be too big. Okay, so 3.2s won't fit into a 7.2, a 7.3. 3.2 will fit into 7.3 2 times. Okay, so the only one that has a 2 point something in the integer, okay, is option B. It fits in there 2 times, right? The next lowest multiple of 3.2 is 6.4 from the 7.3. Alright, let's take a look at number 12. 2.5, if I made this into scientific notation, it would be 2.5 times 10. And then it looks like here, I would move the decimal over 3 numbers, so times 10 to the third. So look at those 2 numbers now in scientific notation. They're exactly the same. Okay, so this one, 12, would be option C. Okay. Number 13. This one is a number, the one on the left here is a number bigger than 1. So if I put my decimal between the 2 for 1.234 times 10, this would be a positive 5. So look at your exponents, a positive 5 and a negative 5. Right? Which one's bigger? The positive is going to be bigger. Okay, so option B for that. Number 14, write this in scientific notation. 6.7, I need a 6.7. There's my exponent, negative 5. 6.7 times 10 to the negative 5. Okay. Number 15. Okay. For number 15, how is this written in standard notation? So let's do the 6.7. Okay. Negative 5 means move left 5 times. Okay, so I'll move it left 5 times. 1, 2, 3, 4, 5. So I would have 4 zeros in front of the 6, right? And there it is, 1, 2, 3, 4. It's option A. Number 16, how is 1.2 E7 written in scientific notation? Well, I need the 1.2. I need the exponent of 7. It would be option D. Number 7, how is 1.2 E7 written in standard notation? Well, 1.2, I move it to the right 7 spaces. 1, 2, 3, 4, 5, 6, 7. So I need 1, 2, 3, 4, 5, 6 zeros. So that's option A. Alright, let's take a look at number 18 and 19. So we're going to look at the table here. Okay, so for the table, which planet has the largest and smallest mass? Well, the largest mass here, it looks like the largest exponent is Jupiter. So it looks like it's either C or D. And then the smallest is between Neptune and Mercury. There's Neptune and there's Mercury. Well, Neptune has the smaller exponent. Okay, so Neptune is the smaller, has the smaller mass. It's option C. Number 19, approximately how many times bigger is Jupiter than Earth? The division one. So if you look at Jupiter, let's say that's about 2. Okay, 2 times 10 to the 27th. And we look at Earth, is about 6 times 10 to the 24th. So divided by 6 times 10 to the 24th. Okay, so we're dividing this 2/6. Well, this is not 6 divided by 2, it's 2 divided by 6. Right, so if I do 2/6, I simplify that, divide by 2 over 2, that gives me 1/3. What's 1/3 as a decimal? 0.3 repeating. Okay, so let me just round that then to 0.3. So 2 divided by 6 is 0.3. Okay, and then if I subtract the exponents, 27 minus 24, 27 minus 24, that gives me about 3. So that's 10 to the 3rd. Okay, so let's put it in scientific notation then. This would be 3. We move this up, we have to move this down, times 10 squared, so that's why it's option A. Okay. Alright, let's go on to the review section. Alright, for number 20, all the bases are the same. And since it's multiplication, we're going to add, okay, the exponents. 2 plus 0 is 0. Okay, 2 plus -5 is a -3. So the base is 2 to the -3 power. So what you do with exponents, you rewrite them as fractions. 1 over 2 to the 3rd power. And then what's 2 to the 3rd power? 2 times 2 times 2. That's 1 over 8. Okay, that's option D. Let's take a look at number 21. The square root of 28. The next lowest perfect square is the square root of 25. The next highest is square root of 36. That's between 5 and 6. The only number between 5 and 6 here, okay, is option C. Number 22, the bases are the same, it's division. Okay, so 5 minus 3 is 2. So this is 4 squared. Okay, 4 squared equals 16. 4 times 4. The other way to look at it is, this is 4 to the 5th. That's 4 times 4 times 4 times 4 times 4. It's being divided by 4 to the 3rd. 4 times 4 times 4. If you cross out each of these 4 divided by 4s gives you 1. Look what you have. 4 times 4 left. 4 times 4 is 16. Either way you look at it, you're going to end up with 16. Number 23, which number is irrational? Well, there's only one with one of those visual indicators. that's a non-terminating, non-repeating number. Okay, so that's option D, irrational. Okay. Remember, for irrational numbers, you have three visual indicators: three dots, pi, or the square root of an imperfect square. We only see that there. All right, number 24. Something x to the third equals 27, and the reason why we're going to do we're going to choose B is because well, let's go ahead and do one wrong one. Okay, so 9 times 9 times 9, okay, does not equal 127. I'm sorry, does not equal 27. Okay, 9 times 9 times 9 gives you 729. Okay, so all of these numbers are way too big. A is too big, C is too big, D is too big. Right? Once you multiply them one time, it'll get you multiply it by itself one time, it'll get you something bigger than 27. So the only one that works is 3 times 3 times 3. 3 times 3 is 9. Times 3 is 27. This is the one we want. Okay. Alright, number 25. Between which two integers is the square root of 24? Well, the next lowest perfect square is the square root of 16. The next highest is the square root of 25. That's 4 and 5. So that's option A. Number 26, the square root of 8. So for the square root of 8, the next lowest perfect square is the square root of 4. The next highest is the square root of 9. That's 2 and 3. Okay, so which of these numbers is between 2 and 3? That's option B. Which one of those points? Okay, it's option B. And then the last one, x squared equals 9. Well, I want you to write two things. 3 times 3 equals 9. Negative 3 times negative 3 also equals 9. Your option, the one that shows that is option D.